Okay, so we came up with a process to date rocks, absolute date them. Where can we find these old rocks? Let's look around. So, due to geologic alteration, plate tectonics, weathering, erosion, recycling of material, most old rocks have been altered or destroyed. That's just the sad fact of it. And remember, Earth is 4.54 billion years old. But the oldest known rocks are only 4.03 billion years old. It's a type of metamorphic rock called gneiss. That's how it's pronounced, G-N-E-I-S-S, pronounced nice, like, oh, that's not nice. So gneiss, the Acasta gneiss, which is kind of the name of the location where the gneiss is found in northern Canada. Gneiss is kind of a metamorphic rock, so it looks a little something like this. This is not exactly the Acasta gneiss, but it is a nice metamorphic rock. I just found it walking around EMCC, but again, found in northern Canada. It's not the 4.54 billion years old, but it's getting there, right? So we have some material that's over 4 billion years old, so up in northern Canada. Extra credit if you can go up there and bring me back a sample in the next few days. Have fun. Well, okay, bummer. So we tried to date a rock. We got something old. Is there anything older on Earth? Well, yeah, there is. Minerals. Now, when we get into unit 4 or 5, I forget, we'll talk about minerals. Minerals are different than rocks. Just for now, just know that. Look at there. Oh, unit 5. Minerals and rocks are different. So, the oldest known Earth minerals are 4.36 billion years old. Bummer. Still not that 4.5 billion years old. Though there's zircon minerals. Zircon is a type of mineral. In fact, it's a one use of zircon as a mineral is as a fake diamond. That's one, kind of looks and acts like a diamond, but it's not. So zircon mineral is found in the Jack Hills of Western Australia. Again, we're getting closer to 4.54 billion years old, but we're not quite there. Frowny face. So here are the Jack Hills area of Australia, just north of Perth on the west coast of Australia. Extra credit if you can go there in the next few days. So this is an example of a zircon under a microscope. Okay. Well, that's the oldest stuff on Earth. Well, crap, where else can we look? How about the moon? Why not? So we went to the moon. How old are those rocks? So the moon doesn't experience the same resurfacing processes that occur on Earth. Plate tectonics, weathering and erosion, etc. Plus, we know that something crashed into the Earth. Material was spewed out into space, and that collectively came together to form the moon. So that is Earth material. So that Earth material, but it's just never been altered. How old is that stuff? So the Apollo and Luna missions returned moon rocks to Earth. So the oldest known moon rocks are about 4.4 to 4.5 billion years old. Still not quite that 4.54 billion years old that we know it to be. So here are some of those moon rocks. Some gorgeous, gorgeous moon rocks. All right. Well, okay. Crap. So where did this number 4.54 billion years come from? Well, we have to look at this timeline. Kind of illustrates. There's Halley, Lord Kelvin, John Jolly. But again, looking at radioactivity, Marie Curie discovers radioactivity. There's Darwin back there. Marie Curie discovers radioactivity. In 1905, we figured out a way to radiometric date things. And in 1953, Claire Patterson estimated the Earth to be 4.54 billion years ago based on the radiometric dating of a meteorite. Remember, as the solar system was forming, it's all kind of about the same-ish age. So if we can figure out if there is some unaltered material out in space, which all the planets kind of formed around the same time, well, maybe that will give us some insight. So again, meteorites contain all unaltered material from the formation of the solar system. So let's see what we got there. So about 50,000 years ago, the Canyon Diablo iron meteorite crashed into Arizona, creating Meteor Crater. If you've ever been there, it's just east of Flagstaff. It's that big crater. So that was the name of that meteorite that hit was called the Canyon Diablo meteorite. It was made of iron. In fact, here's a piece of it right here. Well, in 1953, Claire Patterson, a renowned geochemist, measured ratio of lead isotopes in the sample of the Canyon Diablo meteorite, and the measured ratios of lead isotopes in samples of the meteorite showed an age of 4.53 billion to 4.58 billion years. With further evidence and further dating meteorites, they kind of narrowed it in that gap to 4.54 billion years ago. So that's Meteor Crater. If you've never been there, that's Claire Patterson. That's a portion of the Canyon Diablo meteorite. It broke into a bunch of pieces as it was entering the atmosphere and hit the ground. So you can get your very own piece of history here. So not only is this from space, but this helped to date the age of the Earth. Fun stuff. You know where I got mine? eBay. So in any case, rocks from space. So again, so scientists interpreted that range, 4.53 to 4.58 billion years ago, as the time it took for the solar system to evolve, a gradual event that took place over approximately 50 million years. So by using a combination of Earth and space rocks, kind of really focusing in, scientists have been able to place Earth's age at approximately, here it is, 4.54 billion years. Give or take, plus or minus 50 million years. But what's that between friends, huh? What's that between friends? So hooray! That's where it came from. For comparison, so this is the age of the Earth and the age approximately of our solar system. For comparison, the galaxy that our solar system is in, so the Milky Way galaxy, that's approximately 13.2 billion years old. While the universe itself has been dated to about 13.8 billion years old. That's old. We're not much. What about the oldest rocks in Arizona? So I'm not talking about space rocks, actual ground rocks. So we're in Arizona. Where are there some old rocks? Oldest rocks in Arizona are about 1.75 billion years old. This is some of the basement rocks in the Grand Canyon called the Vishnu basement rocks, just the name of them, and the upper granite gorge of the Grand Canyon. A particular rock in there called the Brahma schist. Schist is a metamorphic rock, and those are about 1.75 billion years old. You got that metamorphic rock and sedimentary layers on top. You have a nonconformity down there. There are actually similarly aged rocks all around Arizona, including in the White Tank Mountains, just off to the west of Estrella Mountain. Maybe you've been over there to the park or to hike in the White Tank Mountains. So you can get some rocks almost that old, some granites and other metamorphic rocks over there, but the oldest for sure are in the bottom of the Grand Canyon. So where do you look for the oldest rocks? At the bottom of the Grand Canyon. So here's a picture of the Brahma schist. Again, it makes up this material down at the bottom of the Grand Canyon. Well, this has been fun, hasn't it? So what are some of the big main ideas as it pertains to stratigraphy and Earth's age? Well, 3 ways to date rocks, right? Relative, geologic, and absolute time. What are the 6 principles of stratigraphy? Kind of remember those. Principle of superposition. Oldest stuff's on the bottom, youngest stuff's on top. Original horizontality, lateral continuity, all of those different things. The different types of unconformities, nonconformity, disconformity, angular unconformity, any ones that we have around here. In the Grand Canyon, I talked about how we have all 3 of them, including a very famous one, the Great Unconformity. The absolute age of the Earth, 4.54 billion years, and the evidence of said age and its connection to Arizona. Now, before we sign off, again, I'm making sure you watched all the videos all the way to the end. Previously, in a video, I gave you a code. I'll be nice. It was a 3-digit code. It had 3 numbers. Whatever that number was, divide it by 2. So put that number into a calculator, divide by 2. Whatever the answer is, that is the super secret code you will need for the assignment. Always watch the videos and listen. Watch and listen to the videos until the very end. With that being said, it's been fun. So ends Unit 4. After this, the assignment and lab will have a test covering units 1 through 4. After the test, when I get into unit 5, then we'll start talking about rocks themselves. This has really been a good once-over, dealing mostly with the tectonic rock cycle and what occurs on Earth, how Earth is shaped. All right. Until next time, adios.